For this question, we've been given the equation L equals AX plus 5p times 7 minus k, and we've been asked to rearrange this equation to find x first of all, then z, then p in terms of all the other variables. So starting off with finding x, we've got L equals AX plus 5p times z minus k. So the first thing we need to rearrange for is AX. So I'm going to take this 5p times z minus k over to the other side. So AX is L minus 5p z minus k. And now to get x on its own, I need to divide it by a. And what I do to one side, I need to do to the other side. Therefore I find that x is 1 over a times L minus 5p z minus k. So that's my first rearrangement. My second rearrangement, I want z. So I'm beginning again with L equals AX plus 5p z minus k. Well, this time I want z, and it's within this bracket, so the first thing I need to do is expand out my bracket. So I get that L equals AX plus 5pz minus 5pk. And that just comes from multiplying 5p by z and 5p by minus k. So what I need to do is get 5pz on its own first. So 5pz will be L plus 5pk, and that's because when I take this minus 5pk over to the left, it becomes plus 5pk, and when I bring this AX over to the left, it becomes minus AX. Therefore, to get z on its own, I need to divide both sides by 5p. Therefore, I get that z is 1 over 5p lots of L plus 5pk minus AX. So that's my second rearrangement done. And finally, the third rearrangement wants me to find p. So again, starting with L equals AX plus 5p z minus k. First thing I want to do is get this 5p z minus k on its own. So we get 5p z minus k is equal to L minus AX. And that comes just from taking this AX from here over to the left hand side. And now to get 5p z minus k, I want to get p on its own, so I need to divide through by 5z minus k. And what I do to one side, I do to the other side. Therefore, my p is equal to 1 over 5 z minus k lots of L minus AX. And so that is my third and final rearrangement.